In this video, we are going to look at the distributive property of multiplication using a model and then using the distributive property without models. So first, I have a model up on the board, and we need to label the width and the length of this model. So the width is 1, 2, 3, 4, 5 units wide, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 units long. One way that we could easily find the whole entire area is just to simply count all of the squares that cover the surface. 1, 2, 3, 4, 5, and so on. However, you will not always have the grids in order, or the squares on the grids in order to count. So we would usually just take the formula for finding area and multiply 5 times 13, the width times the length, in order to find the entire area. For our purposes of modeling the distributive property, however, we're going to break this down a little bit further. In the distributive property, well, one way you can think of the distributive property is to take a multiplication problem and break it down into simpler numbers to work with mentally. So, for example, if we take 13 and break it down into an addition problem, we could think of it as 10 plus 3. Now, the sum of 10 plus 3 is still 13, so I really haven't changed the value. The reason I picked 10 plus 3 instead of, like, let's say 6 plus 7, even though we could use 6 plus 7, is because I was trying to find a number that ends with a 0, because multiplication using patterns of 0 tends to be very, very simple. So in order to keep this problem still equivalent to 5 times 3, I would need to put my 5 times in front of it. I'm sorry, so we still have 5 times 13 up here, and we have 5 times 13 right here. Now, to show the length of 13, I am going to label it over on the top. I'm going to label the length of 10 in red. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is going to be the red rectangle. So I'm going to highlight that in red. So that would be the area of this larger of the two rectangles. So the length was 10. And then I am going to label the smaller rectangle with the length of 3, measurement of 3 right here, 1, 2, 3, and that's going to be my smaller rectangle. And I will shade that one in green. So if I took each rectangle separately, the red one would be 5 times 10, which if I counted all of these individually, I would have 50 squares inside. Over here for the green one, now if this side has a measurement of 5, its opposite side also has a measurement of 5. So I'm just going to move the 5 over here to the opposite side. So 5 times 3 is 15. So this area would have 15 square units. To get the total entire area, of the whole larger rectangle, I would add 50 plus 15, and then I would get 65 units in the shape of squares, so we would call them square units. That would be the entire area. Now, over on the demonstration of the distributive property, we are basically going to do the same thing that we saw in the model. I always tell students when they think of the distributive property to think of the word distribute and what it means. When you distribute something, that means you give it. So basically what we are doing is we are giving the 5 times to each number inside of the parentheses. So we would first give the 5 times to the 10. Now in our model, that's the larger red rectangle. The 5 times 10 right over here. We gave the 5 to the 10 first. Next, we gave the 5 times to the 3. That was our smaller green rectangle right here. We gave the 5 times to the 3. So the 5 times 10 we found was 50, meaning there were 50 units in the shape of squares. And on the green rectangle, we found that 5 times 3 was 15, meaning there were 15 units in the shape of squares. Then to get the total amount, we added those 2 rectangles together, the 50 plus the 15, and as a total we had 65 units that were in the shape of squares, so 65 square units. So they match. So this would be the model that would represent why the distributive property actually works. Now, we're going to do the same exact thing, and let's just take a slightly larger rectangle. But this time our rectangle, instead of having a single digit measurement, it's going to have 2 two-digit measurements. Okay, so let's label the width 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. Let me double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. One thing I notice that many students will do when they're working with models is they will make careless mistakes and not count correctly. So it's always good to count twice, label once, kind of like measure twice, cut once. Now the length is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So we have 21 units. If I were to find the area, I would multiply 15 by 21. However, I'm going to break down the 21 into more manageable addition a more manageable addition problem, and I want one of my numbers to end with 0. So 21 would be 20 plus 1. I haven't done anything to the 15 times, so this is still 15 times 21 as we see up here, 15 times 21. So as I did before, I am going to put the length of the 20 on the opposite side. So here would be my length of 20, and that's going to be my larger rectangle that I'm going to shade in red. So just kind of shade this in quickly. If I leave any white spots, that will be okay. Get most of it shaded in. Okay, so that was my length of 20 on the opposite side. Now, the smaller rectangle, the measurement of 1, and I'm going to shade the smaller rectangle with green. Oops, wrong color. I want to make sure that's in green. Okay, so the area of my larger rectangle would be the 15 times the 20. Well, 15 times 2 is 30 with 1 0 at the end. So for the larger red rectangle, I have 300 units in the shape of squares, or 300 square units. For the smaller rectangle, now remember, if this measurement is 15 units on this side, on its opposite side, the measurement would also be 15 units. So I'll just copy that over here. And now I'm going to multiply the 15 times the 1. I'm going to have to turn this sideways since I don't have much room. And that rectangle has 15 squares, or they're 15 units, square units. So to get the total amount, I would add 300 plus 15, and therefore I would get 315 units in the shape of squares, or 315 square units. So, doing the exact same thing on the distributive property, I'm going to give the 15 times to the 21st, and in essence that is one of our rectangles, putting it in parentheses. Then I'm going to give the 15 times to the 1, which is going to be the smaller rectangle, putting it in green, and then I would add the 2 together. So 15 times 2, let's leave that in red, 15 times 2 was 30, with adding 1 0 at the end, using our patterns of 0 in order to multiply. And then over here, 15 times 1, of course, is 15. So then we add the 2 together. 300 plus 15 would give us 315 units in the shape of squares, or square units. Now, let's look at the same idea, but with a rectangle that has no squares in it whatsoever. So we would multiply 3 times 78. So if there is someone who has trouble using the traditional or the standard algorithm in order to multiply 3 times 78, they could use their knowledge of the distributive property and break it down into 70 plus 8. The larger number into 70 plus 8. We didn't do anything to the 3 times. So now let's distribute, or give each number inside of the parentheses what is on the outside of the parentheses. So the 3 times would be given to the 71st. And remember, in our previous model, that was like the larger rectangle. So we'll put that in parentheses. Next, we'll give the 3 times to the 8. And that was like our smaller rectangle. And then we added the 2 together. 3 times 7 is 21 with 1 0 at the end. So the product of that quote-unquote larger portion of the rectangle was 210. The smaller portion, 3 times 8, basic multiplication fact, is 24. Now, if we add the 2 together, 210 plus 24 would give us 234 units. Now, they would still be in the shape of squares. It's just the squares are invisible. You don't see the grid, but the grid really is there. So the unit is still square units. They're in the shape of squares if you are referring to area. Now, this would work on any kind of rectangle. 11 times 22. Break the 22 down into 20 plus 2. We would give the 11 times to the 21st. Then we would give the 11 times to the 2. We would add the 2 together. So 11 times 2 is 22 with 1 0 at the end. 11 times 2 is 22. Add the 2 together, and you would have 242. In area, it would be square units. So we can apply this to any multiplication problem. If you had 67 multiplied by 4, and let's say once again you were having trouble with the traditional algorithm, we can, and some people would find it easier to use our commutative property and just switch the order of the factors 67 and 4 and rewrite that as 4 times 67. So if we break down the 67 into 60 plus 7 and leave the 4 times out to the left, give the 4 times to the 60, then give the 4 times to the 70 or distribute it. Add the 2 together. 4 times 6 is 24. Add 1 0. 4 times 7 is 28. Add the 2 together. So 240 plus 28 would be 268. And if we do the traditional algorithm, we can see that's correct. Now in the traditional algorithm, or the standard algorithm, you always put the number with the most digits on top as the multiplicand and the one on the bottom as the multiplier. 4 times 7 is 28. Put down the 8, carry the 2 over to the tens column. 4 times 6 is 24, plus 2 would give you 26, and they match. So when you write it out, it appears the distributive property looks much, much longer. However, some people find breaking apart the problem into simpler numbers to work with, they find that a little bit easier than doing the standard algorithm. Hopefully, the distributive property will help you with your multiplication.